Right now, teacher record. Not me. Right now, the student record. It's crazy. Two minutes, good goal for the sprinters. Sub 3. I don't think they'll break. Just practicing all break.
No, it's gonna be like 10 minutes. No. Okay.
That's you finish with a few sub 3s. Three minutes, respectful goals right here. At least we're at important. This game. But you have 3 people done. Four minutes, I do expect you to get by then. Bunch of people done. I'll stop it at 5, and don't forget to write down what you did, just to keep a record for yourself. When you're finished, go ahead and make a really nice graph of y equals sine of x, y equals cosine of x on the back of your unit circle, please. So 5 minutes, I'm going to stop the timer. I do expect you to get it fast at some point. Another V? Is that going up?
No. It's like, you know, that's all.
What?
No. You know, those sounds.
Does this go higher than 1?
No, it's like.
That's
it's
an arrow,
like the,
right?
like stop.
So it's a V. It's a perfect V.
Yep.
Interesting. Try harder.
I see the vision.
Finish the sine and cosine. Once you're done with both of them, just check in with your neighbor, make sure that they're doing theirs correctly. Make sure they have all the points I'm looking for. The shape is, generally speaking, what I'm looking for. Okay. So, what are some tips for speed, unit circle production? So that's been good for you, just so you go around and do all the degrees, all the ratings. Has anyone tried that? So you're not thinking in three different worlds at the same time? Okay. Any other tips? Let's write faster. I don't know. Is it really important to be able to do it at very, very fast unit circle? Is that like, does that make you a great mathematician? So what's the point of doing it, like having a speed trial or speed exercise? Check with your neighbor. What's the point of doing this?
Like, I mean, I never realized it's gonna be a fast enough option for the test we do. So like. You don't really. You just. What?
So what's the point? What's the point of me trying to get you to go faster and faster here? Fun? No idea. But what's the whole point of knowing these values on a unit circle? I mean, what are they used for? Exactly. So if you're looking for sine or cosine values, you get those from the standard places on your circle. Or tangent comes from sine over cosine, yes? Secant, cosecant, you can get all these values. It's just the better you know the unit circle, the better you can perform on future math assessments. There's not that factor. Just you know it. It's good to know your facts. Like multiplication. Hopefully you know your multiplication fact. You're not just like adding stuff. I say 6 times 7, you're not like, uh, you should know. It's 73. Yes, maybe.
Graphs can be applied to.
Yes, absolutely. Yeah. Anything that's periodic motion, like like what? A lot of physics. Yeah. So light waves, motion of the sun, the motion of the solar system, it's all kind of periodic. That's how we know where things are. Great question. Yeah, it's not just for fun, even though we've all just agreed, or at least I agreed that it's fun. The eventual point for all mathematics is really to apply it to something, use it somewhere. Could you please show me your pocket sine wave? Nice, yeah. Your left hand is up, right? So from your point of view, I think you're doing this. Okay. And your cosine, cool. Go ahead and turn to page 6 in your packet and make some nice graphs of numbers 7 and 8. Oh, you finished them already? You did these already? Yeah. After you finish number 7, check in with your neighbor, make sure they did it correctly. I will be calling on 2 people to help me out with these. Number 7 and 8. Check your neighbor about number 7. We finish that one. And also number 8, we finish that one. Number 7, Ella, can you help me with this one, please? What should I mark on the axes before I draw?
Is like the maximum on the y-axis, and -3 is the minimum.
Okay.
And you start at the origin, 'cause it's sine. And then, in the period, you'd solve for by just doing 2 pi over 4. Then you get the period's pi over 2. And then you can divide pi over 2 by 4 so that you can get each part. So the first line's pi over 8, then the middle is pi over 4, and then the next one's 3 pi over 8.
And before you go on, are we good up to there? This is some good stuff. I do want to give you some tips when you're dividing something into 4. First, cut it in half. I do want you to have very even markings. And I know you're not a robot, but I want you to be able to cut things in half fairly well. So I'm going to do this in half and then everything else in half. And like you said, it's pi over 8, then pi over 4, and 3 pi over 8, then pi over 2. Okay, I'm sorry to interrupt.
So the first coordinate is 0, 0. The second coordinate is pi over 8, 3. And the third is pi over 4, 0.
Et cetera, et cetera.
Yeah.
Yeah, once you've labeled your axis, all of those values and the y values, you don't have to say or write the coordinates for me. I see where you're going, especially once you have that first one. You're going in the correct direction. So we just have to make sure that it is something like this. Are we good? Thank you so much. Charlotte, did you get a chance to finish number 8? Did you get started? Okay, can you tell us what you did so far? Okay. Did I make that pretty even? Is that okay? Does it seem okay? Thank you. Okay. And then you got that by right, we divide by whatever that coefficient is. So that gives you 6 pi. Cool. So, and how many pieces will I cut that into? 4. Like that. That should be painful to you to see something like that. That kind of carelessness. Charlotte, I know you didn't do that. Okay, were we able to label these? Okay, well, let's do it. Which one should we label first? There's 1, 2, 3 of them. Which one would you like to do first? Okay, nice. Okay, what's that? Well, you know that the whole thing is 6 pi, so right in the middle is going to be 3 pi. Are we good with that, everybody? Of course, if we're counting by 3 pi over 2, 3 pi over 2, 6 pi over 2, 9 pi over 2. It's not natural to count that way. You're counting by threes, but that's what it is. And if you'd all take your pocket cosine and show me what this looks like, I'd appreciate it. That's the regular cosine that's just been flipped over that x-axis. So now that we have everything set up, we're able to just plug away. So here, here, here. Charlotte, thank you for your guidance. So is it just an upside down V? No, I do want to see that this -2 is at the bottom. So I do want to see some kind of, some indicator that it will be curving back up if we keep going to the left. At the top, make sure that that's the maximum. Curve down. There we go. Any questions? Okay. Let's keep going. Last time we almost started this. Now we're going to do it. I think you could do these. Go ahead and talk about number 1 with your neighbor. What is it?
So basically you just solve for this. They've never gotten. It's gonna
I think because
be
they
is like
I like a period.
because this is actually because I'm how long it takes from middle to get back to where it started. No, because look, so it would end up being 2 pi over 8 and or 2 pi over 8 pi, but
What time? 2 times what is 2 pi to 8. That's 4. If you need sounds like.
wait.
Yeah. Okay. Are we doing all of them?
At least the first one. If you want to keep going, you may.
4, 5.
Oh, wait.
No. Oh, wait. That's sine. It's
One.
Oh, it's negative.
Because the period is 4. It's 3 times 2. So does the next one is 8. That means 3 times.
Oh, wait. Because for it to be, for your swing,
This one.
right? So it repeats that. Oh, you can, so that's that. So 2 pi times 5 is negative 1. So this is.
Oh, so the 2 pies are.
Oh. This one is like 2 pi.
Okay, can we talk about number 1? You've already had some time to discuss. I'd like to hear from Katie. Katie, what did you do for number 1? Where do we even begin? Okay. I say you did like 4. I said y equals 4 something. Now, is this sine or cosine? Are we good with that? Kind of in your head, you say, oh, it's sine. Okay, so I'm sorry to interrupt you. From here, so 4 and then what?
Since the graph goes from -4 to 8, then I have 1.
-4 to 8, is that what you said? Oh, so like from here, the -4 pi to 8 pi? And why are you starting at -4 pi, just out of curiosity? I don't know, should you? Well, we just want 1 period, so is it enough to start at the origin? Yeah, I think so. If I just kind of trace this, I think that gives us our fundamental period. Okay. And from there, you take what away? Like what information do you get from that?
That every x value is multiplied by 4.
Ah, okay.
So then it should be 4 sine 1.
So 4 sine of 1/4. And why 1/4?
Because every x value is multiplied by 4.
Are we good with that? So on the inside, it's the opposite of what you think. So since it's being multiplied by 4, we divide by that 4. Are we good with this? I'm not so sure. Let's check. He's right. Let's check.
Oh.
How could I check?
The amplitude.
Amplitude. How about I just check the point? Like, how could I check this point? Plug in 6 pi. The output should give us -4. Does it do that if I plug in a 6 pi? Then let's see, I get y equals 4 times sine of 1/4 of 6 pi. 1/4 of 6 pi is sine of 3 pi over 2. Did I do that right? How am I supposed to do sine of 3 pi over 2?
Units.
Unit circle. It's right here, where the y value is -1. -4. It's perfect, Katie. Fantastic. Thank you. Are you okay with 2 and 3? Did anyone finish these already? Oh my. I'll call on someone in about a minute, just to let you clean it up. I know, it's 3 problems for this lesson. We should just do the unit circle again and again.
Oh. Wait, this whole day,
The next day.
because we only have one more day. It's like 8 and we get to do this.
Is that what it means?
No,
No, there's 2 more days. There's day 2.
So
and then day
one more day in review.
What in 1 week? That's kind of crazy.
That's pretty crazy.
That's
It's rapid fire.
It's, yeah, it's like 10. It's a week and 1 day.
Yeah, what we're gonna do now. I'm not excited.
We're gonna be doing shifts.
This is the.
Yeah.
Shifts of trigonometric functions.
That's the hard shit. It's not this.
This is different, right? There's a shift there for day 3.
So it's today's.
Oh yeah, today is just these. Yeah.
Oh, forget it.
Okay, for number 2. I do want some help. Okay. Elise, you missed last time. You think you could put this together? Yeah.
So the amplitude is 2.
Okay.
And it's a sine function.
Okay.
And it's reflected over the x-axis. So the y value is multiplied by -2. So it'll be y is -2 sine. And then the like 2 pi times x equals 4. So I just like it's
2 pi times. Okay.
2.
Times whatever that number is equals 4. I like that.
Yeah, I mean I didn't do it. I don't know why I said I just had to
Okay.
myself. But just times 2 and then times 1 over pi
Okay.
give you 4. And then because it's like inside when you write it, it's like the opposite. So it's 1/2 pi x. Sorry.
1/2 pi like this. I'm not sure this equation leads to it. Does that work? Pi over 2?
Yeah.
X equals pi over 2.
Yeah, so
X like that. Okay. What is some math we could use? At least that was great. Yeah.
Just like 2 pi over the period equals, I just like wrote a random constant like b.
Okay. Nice.
So then if it's like 2 pi over 4,
Mhm.
that's just pi.
Very, very nice. Yeah, our parent function is y equals, and it is very common to use a b right there. Yeah, so very nice. Yeah, 2 pi, you just divide that by b, and that gives us our period, which is in this case 4. So we just solve for b. We have b equals 2 pi over 4, or pi over 2. Yeah, so there is a relationship, period equals 2 pi over b. So I'm going to keep, at least that was great. Thank you. And finally, Jojo, help with number 3, please.
Cosine,
Okay,
as the origin, or the first point is not on the origin.
nice.
And then it's also a negative cosine graph because the maximum is on, it has a maximum on the minimum.
Nice. As a maximum on the minimum. Okay, I know what you mean. Okay.
And then the amplitude is 5 over 2. But then
Okay.
in the equation, it's going to be y equals negative 5 over 2 because the graph is flipped.
Okay.
And then cosine. And then the none of the x values have pi on them. So you know that you're dividing all the x values by pi, meaning it would be negative 5 over 2 cosine pi, and then x, because other than the pi, none of the other properties of the x values are changed.
Okay. Does that give us another? I agree with you that there's no pi, but does that give us the period that we're looking for? Are we good? So if we're not sure, it's just the period, which is 2 equals 2 pi over b, which we'll use. I think that does give us pi. Very nicely done. Right there is our period right there. And we could see our fundamental portion of the graph just right there from 0 to 2. So that's the period. Any questions about these? Okay, I do have your tests for you. I give them back to you. And you have time to work on your homework. You have a lot of time, I think.
You said yes.
Are you still? No, that's. Okay, over there. No, no. No, I'm.